According to the National Electrical Code, specifically the 2005 edition, Article 680.26a on, Inground swimming pools are required to have a bonding grid. This grid consists of a minimum of number 8 solid American wire gauge copper conductors installed around the perimeter of the pool, underneath the pool deck. There are exceptions to this rule. One exception is when the pool is constructed on a non-conductive surface. This could be a concrete pad that contains no metal reinforcement. Another exception is if the pool is made entirely of non-conductive materials. Examples of non-conductive materials are fiberglass or plastic. Now, if a pool has a concrete base, even a thin one, and is in-ground, a number 8 copper bonding grid is typically required beneath the pool and surrounding the concrete deck. The bonding grid needs to be connected to all metallic components of the pool structure. This includes any wet niche lighting fixtures. For installation, firstly, the number 8 copper conductors must be run around the perimeter, ensuring a spacing of no more than 10 feet between them. Secondly, these conductors need to be securely connected at every corner and intersection using approved connectors. Thirdly, the entire bonding grid has to be connected to the electrical grounding system at the main service panel. Fourthly, individual conductors should extend from the grid to all metallic parts of the pool structure. Most importantly, any wet niche lighting. Note that the bonding grid should be installed prior to placing the pool vinyl over the concrete base. To elaborate further on the NEC requirements for equipotential bonding of swimming pools, focusing on Article 680 and related sections, it is important to understand the purpose of bonding, which is to create an electrically safe environment around the pool area. The main objective is to minimize voltage gradients in the pool and surrounding areas to reduce the risk of electric shock. Article 680.26 specifically addresses the bonding requirements for metallic parts. This includes the pool reinforcing steel, metal fittings, underwater lighting niches, and any other metallic components within a specified distance of the pool. The bonding conductor must be a minimum size of number 8 American wire gauge solid copper. The connection points need to be accessible for inspection and testing. For the pool structure itself, if the pool has a conductive shell such as one with metallic reinforcing, it must be bonded. This means connecting the number 8 solid copper conductor to the rebar at multiple points to ensure electrical continuity throughout the structure. If the pool walls are non-conductive, like those made of fiberglass or plastic, this requirement may be relaxed. However, any metallic components attached to the pool walls still need to be bonded. The perimeter bonding grid is a critical element for outdoor in-ground pools. This grid consists of a copper conductor, again a minimum of number 8 American wire gauge solid copper, buried in the earth around the perimeter of the pool. It should be located within 3 feet horizontally from the inside walls of the pool and at a depth of 18 inches below grade. The purpose of the perimeter bonding grid is to create an equipotential plane in the area surrounding the pool. This helps to minimize voltage differences that could occur if a fault develops in nearby electrical equipment. The grid needs to be connected to all metallic parts of the pool structure, including the reinforcing steel, metal fittings, and any other metallic components within the specified distance of the pool. For underwater lighting, wet niche and dry niche lights require specific bonding and grounding arrangements. Wet niche lights, which are designed to be submerged in the pool water, must be supplied by a listed low-voltage transformer or power supply that provides electrical isolation. The metal-forming shell of the wet niche light needs to be bonded to the pool's bonding grid. This ensures that the shell is at the same electrical potential as the surrounding water, reducing the risk of shock. Dry niche lights, where the fixture is located outside the pool water, also require a bonding of the metal housing. However, the wiring methods and grounding requirements may be different depending on the specific installation. Any metal fences, ladders, or diving boards near the pool must also be bonded. This includes metal parts within 5 feet horizontally of the inside walls of the pool and 12 feet above the maximum water level. These metallic components can become energized if a fault occurs, and bonding helps to minimize the risk of shock. The bonding connections must be made with listed connectors suitable for direct burial. These connectors should be designed to withstand the corrosive environment around the pool area. Pressure-type connectors or exothermic welds are commonly used to ensure a reliable and long-lasting connection. It is essential to verify the continuity of the bonding system after installation. This can be done using a multimeter to measure the resistance between various points in the bonding grid. The resistance should be very low, ideally less than 1 ohm, to ensure that the bonding system is effective. Regular inspections and maintenance of the bonding system are crucial for maintaining safety. Check the connections for corrosion or damage. Replace any damaged connectors or conductors immediately. It's also important to ensure that the grounding system for the pool equipment, such as pumps and heaters, is properly installed and maintained. Article 680 also covers specific requirements for other types of pools, such as above-ground pools and storable pools. Above-ground pools often have different bonding requirements than in-ground pools due to their construction and location. Storable pools, which are typically temporary structures, may have reduced bonding requirements. However, it's important to consult the NEC and local codes to determine the specific requirements for each type of pool. Ground fault circuit interrupters, or ground fault circuit interrupters, are required for all electrical circuits serving the pool area. This includes receptacles, lighting, and equipment circuits. Ground fault circuit interrupters are designed to detect small leakage currents and quickly disconnect the power, reducing the risk of electric shock. Ground fault circuit interrupters protection is essential for ensuring safety around the pool area. Electrical equipment, such as pumps, filters, and heaters, must be listed and labeled for use with swimming pools. This equipment is designed to withstand the harsh environment around pools and to provide electrical safety. Ensure that all electrical equipment is installed according to the manufacturer's instructions and the NEC. The location of electrical equipment around the pool is also regulated by the NEC. Receptacles must be located at least 6 feet away from the inside walls of the pool. Lighting fixtures must be located at least 12 feet above the maximum water level or be ground fault circuit interrupter protected. These requirements are designed to minimize the risk of electrical hazards near the pool. Local codes and regulations may have additional requirements for swimming pool electrical installations. It's important to consult with the local electrical inspector to ensure that the installation complies with all applicable codes. Permits are typically required for swimming pool electrical work, and inspections are necessary to verify compliance. Understanding and following the NEC requirements for equipotential bonding of swimming pools is essential for ensuring electrical safety. Proper bonding helps to minimize voltage gradients and reduce the risk of electric shock. Regular inspections and maintenance of the bonding system are crucial for maintaining safety over time. Always consult with a qualified electrician for any swimming pool electrical work. Continuing on the topic of swimming pool electrical safety and expanding upon the National Electrical Code, it is important to consider specific scenarios and common mistakes that can occur during installation and maintenance. One critical aspect is the proper selection and installation of grounding and bonding conductors. The NEC specifies the minimum size and type of conductors to be used for various applications. Using undersized conductors or incorrect materials can compromise the effectiveness of the bonding system and increase the risk of electrical shock. Another common mistake is improper connection techniques. The bonding connections must be mechanically strong and electrically conductive. Loose or corroded connections can create high resistance points in the bonding system, reducing its effectiveness. Use listed connectors that are specifically designed for direct burial and ensure that they are properly installed according to the manufacturer's instructions. Proper grounding of electrical equipment is also essential for safety. The grounding conductor provides a path for fault current to flow back to the source, allowing the ground fault circuit interrupter to trip and energize the circuit. Ensure that all electrical equipment is properly grounded and that the grounding connections are secure. One area of concern is the use of extension cords around swimming pools. Extension cords are often used to power temporary equipment, such as radios or small appliances. However, extension cords can be easily damaged or misused, creating a shock hazard. Avoid using extension cords near the pool whenever possible. If an extension cord is necessary, use a heavy-duty cord that is rated for outdoor use and ground fault circuit interrupter protected. Another potential hazard is the presence of overhead power lines near the pool. Maintain a safe distance from overhead power lines to avoid the risk of electrocution. The NEC specifies minimum clearances for overhead power lines above swimming pools and surrounding areas. Be aware of these clearances and ensure that all activities around the pool are conducted safely. During maintenance activities, such as cleaning or repairing pool equipment, always disconnect the power before working on any electrical components. This will prevent accidental contact with live circuits and reduce the risk of electric shock. Use lockout-tagout procedures to ensure that the power remains off while you are working on the equipment. Another important safety precaution is to educate pool users about electrical hazards. Warn them about the dangers of using electrical devices near the pool and the importance of staying away from electrical equipment. Post warning signs around the pool area to remind people of the electrical safety rules. Regular inspections of the pool area can help to identify potential hazards. Look for damaged or frayed wires, loose connections, and other signs of electrical problems. Address any problems promptly to prevent accidents. If you are not qualified to perform electrical work, hire a licensed electrician to do the job. Electrical work can be dangerous and should only be performed by qualified professionals. Electricians have the training and experience to safely install and maintain electrical systems. They can also ensure that the installation complies with all applicable codes and regulations. In addition to the NEC, there may be state and local regulations that apply to swimming pool electrical installations. Be familiar with these regulations and ensure that your installation complies with all applicable requirements. Working with your local building department and electrical inspector can help to ensure that your pool is safe and code compliant. Staying up to date on the latest electrical codes and safety standards is essential for maintaining a safe swimming pool environment. Attend training courses and seminars to learn about new technologies and best practices. Share your knowledge with others to help promote electrical safety in your community. By following these safety guidelines and taking precautions, you can help to prevent electrical accidents and ensure that your swimming pool is a safe and enjoyable place to relax and have fun. It's also crucial to understand the specific requirements for different types of pool equipment. Pool pumps, for example, require dedicated circuits and proper grounding. The pump motor must be protected by a ground fault circuit interrupter to prevent electrical shock hazards. Heaters, whether electric or gas-fired, also require specific electrical connections and safety features. Electric heaters must be properly grounded and protected by a ground fault circuit interrupter. Gas heaters require a bonding connection to the pool's bonding grid to prevent stray currents from causing corrosion. Saltwater chlorinators, which are becoming increasingly popular, also require careful attention to electrical safety. These systems generate chlorine through electrolysis, which involves passing an electric current through salt water. The chlorinator cell must be properly grounded and bonded to the pool's bonding grid to prevent electrical shock hazards. Automated control systems, which are used to manage various pool functions such as filtration, heating, and lighting, also require proper electrical connections and safety features. These systems often involve complex wiring and control circuits, so it's important to follow the manufacturer's instructions carefully and ensure that all connections are secure. Another important consideration is the use of low-voltage lighting around the pool. Low-voltage lighting can provide a safe and energy-efficient way to illuminate the pool area. However, it's important to use listed low-voltage lighting fixtures and transformers that are specifically designed for outdoor use. The wiring for low-voltage lighting must also be properly installed and protected to prevent damage or shock hazards. When installing electrical equipment around the pool, be sure to use weatherproof enclosures and fittings. These enclosures are designed to protect electrical components from moisture, corrosion, and other environmental factors. Use conduit to protect wiring from physical damage and ensure that all connections are properly sealed to prevent water from entering the enclosures. Regular maintenance of electrical equipment is essential for safety. Inspect wiring, connections, and equipment for signs of damage or corrosion. Replace any damaged components promptly. Clean electrical equipment regularly to remove dirt, debris, and other contaminants. Test ground fault circuit interrupters regularly to ensure that they are functioning properly. Ground fault circuit interrupters should be tested monthly by pressing the test button and verifying that the circuit trips. If a ground fault circuit interrupter fails to trip, it should be replaced immediately. In addition to electrical safety, it's also important to consider other safety aspects of swimming pools. Install fences and gates around the pool to prevent unauthorized access. Use non-slip surfaces around the pool deck to prevent falls. Provide adequate lighting around the pool area to improve visibility at night. Keep rescue equipment, such as a reaching pole and a life preserver, readily available. Learn cardiopulmonary resuscitation and other first aid techniques to be prepared for emergencies. Supervise children closely when they are in or around the pool. Never leave children unattended near the pool, even for a few minutes. Enforce safety rules and regulations to prevent accident. By following these safety guidelines and taking precautions, you can help to create a safe and enjoyable swimming pool environment for everyone. Remember that electrical safety is an ongoing process that requires vigilance and attention to detail. Stay informed about the latest codes and standards, and always prioritize safety when working with electrical equipment around the pool. Continuing on the subject, let's explore some specific scenarios related to bonding and grounding in older swimming pools. Older pools may not have been built to the same electrical safety standards as modern pools. As a result, they may lack adequate bonding and grounding systems. If you have an older pool, it's important to have it inspected by a qualified electrician to determine if any upgrades are necessary to bring it up to current code requirements. One common issue in older pools is the lack of a perimeter bonding grid. As previously discussed, the perimeter bonding grid is a critical element for creating an equipotential plane around the pool. If your older pool does not have a perimeter bonding grid, it may be necessary to install one. This can involve digging trenches around the pool and burying the bonding conductor. Another issue in older pools is the use of outdated wiring methods. Older pools may have wiring that is not rated for outdoor use or that is damaged or corroded. It may be necessary to replace the wiring with modern, code-compliant wiring. Additionally, older pools may not have ground fault circuit interrupter protection. Ground fault circuit interrupters are essential for preventing electrical shock hazard. If your older pool does not have ground fault circuit interrupter protection, it's important to install it. Ground fault circuit interrupters can be installed at the circuit breaker panel or at individual receptacles. Another area of concern in older pools is the condition of the bonding connections. Over time, bonding connections can corrode or loosen, reducing their effectiveness. It's important to inspect the bonding connections regularly and replace any that are damaged or corroded. Additionally, older pools may have metal components that are not properly bonded. This can include ladders, diving boards, and other metallic parts. It's important to bond all metal components to the pool's bonding grid to ensure that they are at the same electrical potential as the surrounding water. When upgrading the electrical system in an older pool, it's important to follow all applicable codes and regulations. This may involve obtaining permits and having the work inspected by a qualified electrical inspector. Working with a qualified electrician can help to ensure that the upgrade is done safely and correctly. In addition to upgrading the electrical system, it's also important to address any other safety issues in older pools. This may include repairing or replacing damaged pool surfaces, installing new safety fencing, and upgrading the pool's lighting system. By addressing all safety issues, you can help to ensure that your older pool is a safe and enjoyable place to relax and have fun. Remember that electrical safety is an ongoing process that requires vigilance and attention to detail. Stay informed about the latest codes and standards, and always prioritize safety when working with electrical equipment around the pool. The principles of bonding and grounding extend beyond just the pool itself. Any structures or equipment near the pool, such as patios, decks, or outdoor kitchens, must also be properly bonded and grounded. This helps to create a consistent electrical potential throughout the entire pool area and prevent dangerous voltage differences from developing. For example, if you have a metal patio cover near the pool, it must be bonded to the pool's bonding grid. This ensures that the patio cover is at the same electrical potential as the pool water, reducing the risk of shock if someone comes into contact with both at the same time. Similarly, if you have an outdoor kitchen near the pool, all metal appliances and equipment must be properly grounded. This includes refrigerators, grills, and other electrical devices. Grounding provides a path for fault current to flow back to the source, allowing the ground fault circuit interrupter to trip and to energize the circuit in the event of a fault. When installing electrical equipment near the pool, be sure to follow all applicable codes and regulations. This may involve using weatherproof enclosures and fittings, running wiring in conduit, and providing ground fault circuit interrupter protection. Working with a qualified electrician can help to ensure that the installation is done safely and correctly. In addition to bonding and grounding, it's also important to consider the location of electrical equipment near the pool. The NEC specifies minimum distances for receptacles, lighting fixtures, and other electrical equipment from the pool's edge. These distances are designed to prevent accidental contact with electrical equipment while swimming or using the pool. For example, receptacles must be located at least 6 feet away from the inside walls of the pool. Lighting fixtures must be located at least 12 feet above the maximum water level or be ground fault circuit interrupter protected. By following these guidelines, you can help to create a safe and enjoyable pool environment for everyone. Finally, it's important to remember that electrical safety is a shared responsibility. Pool owners, operators, and users all have a role to play in preventing electrical accidents. Pool owners and operators should ensure that the pool's electrical system is properly installed and maintained. They should also provide adequate signage and warnings about electrical hazards. Pool users should follow all safety rules and regulations and avoid using electrical devices near the pool. By working together, we can help to create a safer swimming pool environment for everyone.